So the first slide here is a theorem. Again, the number isn't important to us. This one's nice because it has a name, and this one's called the triangle longer side theorem. So what this theorem says is if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. So if all they're asking you to do is use the information that's in the picture right here to compare the two angles, what you're going to do is you're going to look at the side and you're going to figure out what angle is directly across from it or opposite. So opposite of 10 would be B, and then opposite of the 12 would be angle C. So because, let's see, AB is bigger or greater than AC, AB is 12, AC is 10. So because 12 is bigger, then the angle across from the 12, which is angle C, is going to be bigger than angle B. So the side across from the angle will tell you where it's going to fall, as far as the smallest or the biggest. The next slide, again, another theorem. Again, the number's not important. This one is called the triangle larger angle theorem. So this one now is going to be giving us the angle measure, and then we have to decide which side is bigger. So if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Now, what's going to be important here is we need to use our triangle sum theorem. So if they're only asking you to compare the two angles that are across from the given angle, so for example, across from angle A is going to be side BC, and across from angle C is going to be side AB. So if they're only asking you to find which one is bigger between these two, then we just use the numbers that are there. Now I'm going to give a little spin on this after I do this. So for example, angle C, the measure of angle C is 60, and the measure of angle A is 30, and since angle C is bigger, then I know the side across from it, which is AB, is going to be the bigger side. Now, in the homework though, and coming up also in the notes, they may ask you to find the biggest side of the entire triangle. So if that were the case on this problem, what I would need to do is figure out what angle B equals. And the way that I can do that is I will add 30 plus 60, and I will subtract from 180. And I know it doesn't look like a right angle, but angle B is a 90-degree angle. So if they ask you to find the biggest side out of the triangle, then you need to make sure you have all three angles. And the biggest side is actually side AC, because it's across from the biggest angle. So if they ask you to order the side lengths from greatest to least, you would say AC is the biggest. Then you would say coming up next would be AB, because it's across from the 60, and then the smallest would be BC. So you could write it like that. So whenever you're doing the homework, you need to find the missing angle first, and then compare the sides. The last theorem. And the last theorem, again, don't worry about the number. Memorize the name. The triangle inequality theorem. So the sum of the lengths of any two sides of a triangle is always greater than the length of the third side. So what all these inequalities over here on the bottom mean is if I were to add BC plus AC, that sum should be greater than the other side that I didn't add together. And then if I were to add AB plus AC, it would have to be greater than the third side BC. And lastly, if I were to add AB with BC, it needs to be greater than AC. When we go to do the homework, I'm going to show you a shortcut so you don't have to show every single inequality. What we can do is we can add the two smaller sides and subtract them, and the third side must be in between because they're going to ask you to write an inequality. But it's simple math. Nothing too difficult here. So now we're going to apply these theorems. So the first one is asking us to name the largest angle and the smallest angle. So the first thing I need to do is find my biggest side. My biggest side in this triangle is 10. This is what I'm going to be using to find the largest angle, and the largest angle will be across from that biggest side, and it's going to be angle C. Then to find the smallest angle, I'm going to find the smallest side length, which is 6, and you can see that the 6 is across from angle B. All right, so the next one, it says to name the longest and the shortest side. Now, this is where we need to find angle T before we decide which one's biggest or smallest. So I need to add 46 plus 105. I get 151. I'm going to subtract that from 180 because that's what the three angles need to add up to be. And I get 29. So angle T is 29 degrees. That made a difference in my answer because now the smallest angle is angle T. So to find the longest side, I'm going to find the biggest angle, and the longest side will be across it. And you can either name it as IT or you could call it TI. Then for the shortest side, that's going to be that 29 degrees. And the shortest side is IJ, or you could call it JI. Let's try another example. It wants us to fill in the blank with either a less than, an equal to, or a greater than symbol. Now, notice they did not give me a picture of a triangle, but they told me triangle ABC is a right triangle. So let me go ahead and give myself a visual. They also told me that angle C is the right angle. Now, if they were asking us to identify which angle is smallest, I couldn't do that. But I do know from prior knowledge that the two acute angles of a right triangle are complementary. So I do know from my picture here that angle A plus angle B equal 90 degrees. Because if you have a right triangle and you already subtract out the right angle, that tells you you have 90 degrees left for the other two. So that's all the information I need to answer this question. I don't need to know the exact number for A and B. So I know that angle C, when it's a right triangle, is always going to be the biggest angle, and the biggest side is this hypotenuse. So angle C is the largest angle in a right triangle, and it's going to be greater than either A or B. And then I know that angle C is 90, and then I also know that angles A plus B are also 90, so this one's equal to. And then the last one, since angle C is the biggest angle in the triangle, I know that side AB is the biggest side. It's the hypotenuse. Here, if the question were, is CA blank BA, the order doesn't matter. AB or BA is still the biggest side. Let's try the next one. This is using the triangle inequality theorem. Now here it says the lengths of two sides of a triangle are going to be 8 and 13. Then the length of the third side must be greater than what, but less than what. Here's how we do it. You're going to take the two side lengths they gave you. You are going to add them. And you are going to subtract them. The third side must be greater than the difference. So it's got to be greater than 5. And less than the sum. Actually, that should be a 21. So the third side length has to be a number between 5 and 21. It can't equal 5, it can't equal the difference, and it cannot equal the sum. So a third side length of this triangle could be a 6, it could be 7, 8, 9, 10, all the way up to 20. And these could be all side lengths. And they could have fractions. They could be like 5.5. But any number in between 5 and 21, not including 5 and 21. So it's got to be greater than the difference and less than the sum. All right, so what they want us to do here is check to see if these are good numbers for a triangle. And the way that we're going to check them is we're going to take the two smaller numbers, we're going to add them, and we're going to subtract them. So for number 1, I would be doing 8 minus 6 and 8 plus 6. And I need to see if 10 would be in between here. And it is. It is a number between 2 and 14. So yes, these are good sides to form a triangle. Now sometimes the side lengths aren't going to be given to you in order from least to greatest. This one is. And again, I'm going to do the same thing. I'm going to subtract the numbers and I'm going to add the two smaller numbers. 4 minus 3 is 1. 4 plus 3 is 7. However, 8 is not in between 1 and 7. So this one is no. These could not form the sides of a triangle. The next one, I'm going to do the same thing. I'm going to add and subtract the two smaller numbers. So I'm going to do 4.1 minus 2.5, and I get 1.6. And then I'm going to also add them, and I get 6.6. Because 5.0 is in between 1 and 6.6, this one is yes. These three numbers could form the sides of a triangle. Now look at D, that it's not in order. Remember, you're going to add and subtract the two smaller numbers. So here I'm going to subtract 4 minus 2 and add 4 plus 2. Because 4 plus 2 equals 6, and this is kind of light, it can't equal that number, so this one is no. And then the last one, again, take the two smaller numbers, I'm going to add and subtract 6 and 5. So 6 minus 5 is 1. 6 plus 5 is 11. So because 6 is in between, this one is yes. And that is it for section 6.5. Yes?
I have a question. For E, why wouldn't you add 6 plus 6?
You need to add the smaller of the 3 numbers. You pick the 2 smallest.
Okay, thank you.
You're welcome. Now, also, if you happen to look at your e-textbook, in your textbook, section 5 includes indirect proof. We do not cover indirect proof. Proofs as it is are really challenging. Indirect proof, you've got to think backwards, and it's a little bit confusing. So really what you would see more often on a standardized test or in the future would be just a straight proof, not an indirect proof. So we do not cover indirect proof for anyone who was reading through their textbook. We're not going to cover that part of this lesson. Any questions?